Good morning, everyone. I am Maria Cristina Reynera, and I'll be discussing all about UML dynamic modeling notations under MIT, Advanced System Design and Implementation. Let's have a recall of our previous discussion from one of our classmates. OCL is a type and declarative and side effect-free specification language type means that each OCL expression evaluates the type and the most conform to the rules and operations of the type. Side effects free implies that the OCL expression can query or constrain the state of the system but not modify. In relation to the UML meta model, each OCL expression is written to the context of the instance of a specific type. In an OCL expression, the reserved word itself is used to refer to the contextual instance. An invariant is a constraint that should be true for an object during its complete lifetime. It's often to represent rules that should hold the real-time object after which the software objects are molded. So in this kind of chapter 4, the one that we're going to discuss for today, we will complete the introduction of the UML notification by describing the model language used to define dynamic behavior of system. What are those? State charts, or what you call the state machines, collaborations, and sequence diagram. Now we're going to discuss first the first one, which is state charts. So if we're going to discuss what is state charts, it focuses the dynamic behavior of the project and graphically represents the life history of the object over time and their patterns of intercommunication. So it is used for the real-time design such as robotics, GUI designs, UI designs like screens and modes. Now, as you can see in the graph, a graph right now, these are the elements of a state machines. So what are the different parts? Let's start with the first one. So the first is what you call states. This is the rounded corner boxes containing the state name. Next is, of course, to have a flow, we're calling it transitions. Transitions arrows from one state sources to transition to another. Target labeled with event that causes the transition. And last but not the least, of course, the default initial state. This one is a state of the object at start of its life history. Termination of these site machines can be shown by using the bullseye symbol. There are different kinds of dynamic modeling notation. So it's divided into two kinds. First is the protocol state machines, and another one is behavior state machines. If we say protocol state machines, it describes allowed life history of object of a class. Events on transitions are operations of the class. Transitions may pre or post conditions. The best rule is to define when, on which conditions can individual behavior features on owning instance to revoke. On the other hand, behavior state machine, it describes the operation, executions, and implementations of objects behavior. Transitions do not post conditions, but can have action. So it defines the behavior of the focus on how the states of system changing as a reaction to the event occurrences. So in other words, state machines describe the behavior of the object of a particular class, or probably it's an execution processing the operation. Let's take a look at my example. I got this one from javatpoint.com. It's an example of top-level state machine diagram showing bank automated teller machine. Initially, the ATMs turned off. So, of course, after having a power supply, it will perform and will have the self-test state. Like what we're doing in our computers. We open the AVR, we open our CPU, and it will run the BIOS. If the test fails the ATM, it will go to out of service. Now, so whenever the customer insert the bank or credit card in the ATM's card reader, the ATM will change for idle to serving customers. Now, the transaction now will run through. Now, for that one, so the customer authentications and the transactions are composite state itself displayed by a hidden decomposition indication icon. After the transaction is finished, the serving customer encompasses the triggerless transaction back to the ideal state. On leaving the state, it undergoes the exit action eject card that discharge the customer card. So for this one, in the event of the protocol, state chart normally corresponds to the operations or methods of the class whose behavior is a state chart describes. The semantic meaning of a protocol state chart attached to a class is that each object of the class begins life history in default states of a state machine. Let's take an example, as you can see in my graph right now, this one. Traffic lights are usually time or traffic responsive. So when signals are operated exclusively on timers, each direction is allocated in a specific period of green time, regardless of traffic conditions at any particular time. Signals are in the traffic responsive, operating using the combination of vehicles, sensors, or probably timers. And we know that the green, if there is a green, this is the time wherein you will be able to drive and cross the intersection or probably turn into a corner. After a few minutes, then the next light will be amber or yellow. This color will signify the driver that he or she needs to slow down, because the next color, it will be a full stop, which is red. So this color stop the vehicles at a certain point, usually in the passage of the vehicles or the other sides of the road or intersection, and it will go back, and it's like a system already. Okay, so for the next one, of course, the transition and guards and actions. So transition from one state to the next are denoted by lines with arrowheads. A transition may be a trigger and a guard and an effect, as you can see in the picture. Trigger is the cause of the transition, which should be a signal and event that is change in condition or the passage of the time. Guard is condition which must be true in order for the trigger to cause the transitions. And the effect. And the effect is an action which will invoke directly the object that owns the state machine as a result of the transitions. So as you can see in this example, an effect was associated with the transition. If the target states had many transitions arriving at it and each transition had the same effect associated with it, it would be better to associate the effect with the target state rather than having transitions. So these can be done by defining the entry action for the state. So the diagram that you can see right now, it shows a state with an entry action and an exit action. So now the question is, what are the rules applied to states within a state machine? So what are the things that we need to consider? States can occur in any order within an enclosing order, but the order in which they listed, it doesn't affect the order in which they run. The content of the state determines this order. Within a machine, there can be only one state that designated as the start of the state, designated the value of the start in the top level structure. Which state is the one that executed first, and when executed starts? Then if the state machine consists of only one state, it can be both start can be both start the state start and also the end state. So now, is it possible to always use the state machine? When to use or not to use the state machines? Yes, you can use the state machines if an early storage of the software development when behavior of an object or operation is not well understood yet. So it's more on planning it until in the procedures more on planning. But do not use the state machine when there are several things involved. So the advice is you should do diagrams instead. Okay, so let's have a refresh of what I discussed to you today. So the first, I'm just going to give you three questions, and you just need to answer which is if it's true or false. Are you ready? Okay, so let's proceed with the first one. True or false? State charts compose on dynamic behaviors of object and graphically represents the life history of object over time and their patterns of the intercommunications. Okay, if your answer is true and you got the correct answer, of course, it focuses with the dynamic behaviors. Okay, next, let's proceed with the number 2. UML divides states machine into 3 kinds. We have the protocol machine, behavior state machine, and state diagram. Okay, if your answer is true, that is incorrect. Why? As I mentioned a while ago, UML divides state machine into 2 kinds only. So we have the protocol machine, which describes the allowed life history of an object of a class, and the other one is behavior state machine, which describe the execution, implementation of an object behavior. And let's proceed with the last question. One of the rules applied to states within a state machine is your state machine consists of only one state. It can be both the start state and the end state. Okay, if your answer is true, that is correct because most likely we can consider it as a state and the end state. What can you say about composite states? So it's a nested within others to express relationships of generalization or specialization or to simplify diagrams. It is a state that contains one or more other substates. It can be used to the group states into logical compound and thus make a state chart and more comprehensible. When a composite state is entered, its entry node denotes a substate to be activated. The composite state can simply multiple entries, yes, and nodes with unique names. Incoming transitions of the composite state can simply the desired entry node to take for the entry of the composite state. As you can see in the graph, shows an example of composite state of containing substate standby and no power. When switch off occurs in state on simply goes to standby. And it will be default state is still off. When the switch on occurs, if the system is in either standby or no power, then the next state is on. So the nested state notation therefore reduces the number of the transitions arrow by 1 in this case. Now let's take a look of another example. I got this an example from Mr. Kevin Lano. This is an sample state machine of BSc students with a 3-year course. So states year 1, year 2, and year 3 have substates of studying. States interrupted and terminal graduated at top level and transitioned for progression, repeating year, interruption, and graduation. As you can see, graduate transition only occurs when you reach year 3. Final stage shows in a bullseye. Remember we discussed this one before. History, this area, state denoted by each symbol with circle. The transition to history state can actually target the most recently occupied state of composite state containing the history state. When students resume their studies, they will return. They were in. What will be the level interrupted? So that is also the purpose of using the history, and we're going to talk about it more later on. Now, let's move on to another state. So we called another state nested state. So it seems that it's really a programming, right? So if it's a nested state, it is used to model the complex system as a regular state diagram inadequate and describing a large complex problem. So for the better understanding, I got an example from binaryterms.com, an example of vending machine diagram. So at the beginning of the machine is idle. Now a person come and insert some coins into the vending machine and select an item. If the selected item is not available or the amount inserted is insufficient, then the machine would wait for the person to take another action. If the amount is sufficient and the item is available, then the machine would dispense the selected items and deduct the required amount for the inserted amount and would return the remaining change. Now observe the lower graph. The state dispense have multiple substates. So from a state, there is still a substate under. So it's expanded in the lower level state diagram, which is also termed as submachine. The term submachine is defined as a state diagram which is triggered by another high level state diagram. Like what can you see right now? So there's another states. Yeah, we have really encountered a lot of states. Now another state is what you call history states. So when you like a while ago, if you still remember, the student from year 1 to year 3. So these history states allow the state machine to re-enter the lab substate that was active prior for to leaving the composite state. It is used to remember the previous state of a state machine when it's interrupted and written as an H with a circle. So the graph that you can see right now, it is an example of state chart describing the life cycle phases of a product. The development process consists of 4 phases. If the product development is suspended, the state chart control is passed to the suspended state. When the company decides to resume the product development, the resume transition is taken. The control is passed to the history state inside the composite new product development statement. This history state instantly passes the state chart control to the state that was active when the product development was suspended. Now, let's move on to the next part of the UML dynamic modeling notation, which is the interaction diagram. So what does it mean by this kind of diagram? So this type of diagram capture the interactive behavior of a system. Interaction diagram focus on describing the flow of the message within a system, providing the context for one or more lifelines within a system. In addition, interaction diagrams can be used to represent the order sequences within a system, and it acts the means of visual real-time data via UML. So the purpose of the interaction diagrams are follows: to capture the dynamic behavior of a system, to describe the message flow in the system, to describe the structure, organization of the system, and to describe the interaction among objects. So there are two kinds actually of the forms of interaction diagram. First is the sequence diagram, and the other one is collaborative diagram. So what is the difference of these two? So sequence diagrams emphasize timing and history of object. This diagram consists of the group of objects that's represented by lifelines and the messages that they exchange over time during the interaction. On the other hand, collaboration diagram emphasize the structural aspects of the interactional diagram, focusing on the object's architecture rather than the flow of the messages. So let's talk about the first diagram, which is the sequence diagram. So sequence diagram revolve around the 5 main events. We have the order placement, the payment, order confirmation, order preparation, order survey. If the sequence of event changes, it can cause delays, or probably it may the system crash. It is important to select the notation that matches the particular sequence within the diagram. So in this kind of diagram, what is the benefit? What is or are benefits now? So first is these are easy to maintain and generate. This is also easy to update according to the change in the system, and also it allows for the reverse and forward engineering. However, there are also possible downsides. So first, they can become more complex with too many lifelines and variations. And at the same time, it it's easy to produce incorrect that depends on your sequence being entered correctly. So now let's move on to the another one, which is the collaborative diagram. So there are three primary elements of collaborative diagram. We have the objects, links, and messages. If we talk about objects, objects participating in collaborating come into two things: suppliers and clients. Objects are the objects that supplies the method of being called and therefore receive the message. On the other hand, client objects call methods on supplier objects and therefore send messages. We have also the other one, which is what you call links. So the connecting lines drawn between the object in a collaboration diagram are what you call links. These kinds of links, it gives a part for the sequence diagram. It enables you to see the relationship between different objects. Each line represents a relationship between the objects and symbolizes the ability of objects to send messages to each other. A single link can support one or more messages sent between the objects. This is from the sequence diagrams where the line drawn between the objects represent messages sent from one object to another. And of course, we have the messages. So in the messages, in the collaboration diagram, it shows the arrow pointing from the client object to the supplier object. Typically, messages represent a client invoking an operation on a supplier objects. So what are the benefits of that one? So it emphasizes how Lifeline connects. It also focuses on the elements within a system rather than the message flow. And also it provides the added emphasis to organization over the thing. However, it can also become a complex also as well. It makes it difficult to explore and also it can be a time consuming to create. So before we continue, so let's have a recall of our discussion, which is the interaction diagram. So I have here a 5-item quiz. Yeah. And let's try our best to get the correct answer. So let's start. Which of the following diagram is time-oriented? Number 1, sequence. Number 2, activity. Number 3, collaboration. Number 4, none of the above. You have 5 seconds to answer the question. If you answered the sequence, that is correct. Number 2, which of the following statement is true? Transitions may be spontaneous, but usually come event triggers them. Number 2, a transition is a change from one state to another. Number 3, an event is a noteworthy occurrence at a particular time. Events has no duration. Or number 4, all of the mentioned. Again, you have 5 seconds to answer the question. If you answered all of the mentioned, you got the correct answer. Number 3, what is an interaction diagram? Number 1, all of the mentioned. Number 2, interaction diagrams are the UML notations for dynamic modeling of collaboration. Number 3, interact diagrams are a central focus in engineering design. Number 4, none of the mentioned. Again, you have 5 seconds to answer the question. Okay, so if you answer all of the mentioned, you got the correct answer. Number 4, what is a sequence diagram? So number 1, a diagram that shows interacting individuals along the top of the diagram. Number 2, a diagram that shows messages superimposed on the diagram. Number 3, a diagram that shows the change of an individual states over time. Number 4, all of the above. Again, you have 5 seconds to answer the question. Okay, if you answered the number 1, you got the correct answer. And last but not the least, which diagram is used to show interaction between messages are classified as? Number 1, collaboration. Number 2, object-oriented. Number 3, activity. Number 4, state chart. Again, you have 5 seconds to answer the question. If you answered the word collaboration, yay! I hope you got the correct answer. So let's move on to the last part of our discussion. This is what you call the behavioral diagram. So what is this kind of a diagram? So it shows the dynamic behavior of the object in a system, which can be described as a series of change to the system over time. It is used to as a case diagram or a sequence diagram, show how the system works in motion, and that is how the system interacts with external entities and users, and how it responds to the input and constraint it operates under. So one of the models under of these ones is what you call the activity diagram. So we're going to define what does it mean by this one. So if you say activity diagram, it helps people on the business and development side of an organization come together to understand the same process of behavior. So activity diagrams represent the number of benefits of the user. Considering and by creating this kind of diagram demonstrates the logic of an algorithm. It also describes the steps performed in the UML use case. It illustrates the business works or workflow between users and the system, and it simply and improve any process by clarifying complicated use cases and model software architecture elements such as methods, functions, and operations. Now, what are the basic components of this kind of diagram? So we have actually 5. We have the action, decision, control flows, start node, and end node. So before we begin to understand more that activity diagram, we should understand first the components. So we'll go first with the action. So action, it is a step of an activity wherein the user of the software perform a given task. Okay, so this one in some applications that I've seen, they uses a symbol of round edge rectangles. Then the next one is decision mode. So if we say decision mode, it's a condition branch in the flow that is represented by a diamond. Usually we can we usually use the diamond in flowcharts and etc. Next, control flows. So if you say control flows, this is another name for the connector. So this is composed of arrows. Then the last but not the least, the start node symbolizes the beginning of the activity. So it represents the black circle. And the last but not the least, the end node, which represents the final step in the of the activity. Now, to have more discussion about the symbols, I'll be showing to you some as or the most common symbols that they were using in activity diagram. So the first that you can see, I know it's long, but yeah, let's take a look of this one. So of course, these activity diagram shapes and symbols are the most common type to find the you can see, yes, you can see in UML diagrams. So let's start with the first one, which is the circle. We call it start symbol. It represents the beginning of the process of flowchart in an activity diagram. It can be used by itself or with a note symbol that explains that is a starting point. So the next one that we have is the activity symbol. So it indicates the activities that make up the model process. So these symbols, which includes the short description within the shape, are the main building block of an activity diagram. So we have the third one, connector symbol. So it shows the directional flow or the control flow of the activity. An incoming arrow starts at the step on an activity once the step is completed. So it follows the flow continues with outgoing arrow. So the next one to your right side is the joint symbol, or what we call synchronization bar. So this one, it combines two concurrent activities and reintroduces them to a flow where only one activity occurs at a time. So it represents, as you can see, with a thick vertical or horizontal line. Now we have also what you call the fork symbol. So symbol, it splits a single activity flow into two concurrent activities. So it symbolizes with the multiple arrowed lines from a joint. The next, of course, decision symbol. So it represents the decision and always have at least two paths branching out of with the condition that allows the users to view the options. So this symbol represents the branching of merging of various flows with the symbol acting as a frame or a container. So let's move on to the next part. So we have the node symbols. So node symbols, it allows the diagram creators or probably collaborators to communicate additional messages that don't fit within the diagram itself. So it leaves nodes to add, clarify, or specification in a certain process. So next is the send symbol signal. So for the send symbol signal, it indicates the signal that's being sent to a receiving activity. So of course, if there is a send, but there's also a receive. So for the receive signal symbol, it demonstrates the acceptance of an event. After the event is received, the flow that comes from this action is completed. So we have also, if you still remember this one, the H with circle. Yeah, from the first part of our discussion, that's what you call a shallow history pseudo-state symbol. So it represents a transition that invokes the last active state. So it can go back if ever that it can go back to the previous functions. Yes. Next is options loop symbol. It allows the creator to model a repetitive sequence within the option of the loop symbol. And we have also the flow final symbol. It represents the end of specific process flow. So this symbol should not represent at the end of all the flows in an activity. In the instance, you would use the end symbol instead. So the flow final symbol should be placed at the end of the process of a single activity flow. So I think this will be the second to the last. So we have also the condition text. So if you say condition text, it's placed next to the decision marker to let you know it's under what condition activity flow should split off in the direction. And the last but not the least, the end symbol. It marks the end state of an activity and represents the completion of all flows of a process. So if you're going to look at it, if you notice, this is almost the same of what we know before. What is like the flowchart. So what now is the difference of the two? So let's take a look of this next slide. So I got this from Pedia, yeah, pedia.com. It's a comparison between the activity diagram versus the flowchart. So it says here for activity diagram, a graphical representation of the workflows of stepwise activities and actions with the support for choice, iteration, and concurrency. But in the flowchart, a diagrammatic representation that illustrates a solution model to a given model. Okay, an activity diagram is a graphical representation of workflows of stepwise activities, like what I mentioned, right? Thus, if we're going to compare with the flow chart, so the main difference is between the activity focuses with the activity itself, and the flow chart, it focuses with the designing. So in terms of usage, activity diagrams helps to understand the business process. So while the flowchart, it helps to analyze the design of the program. And last but not the least, if in regards with association, another difference between of the two is that the activity diagram is associated with UML. But in the flowchart, it is associated with the programming. So with this kind of conclusion, so the main difference between the activity diagram and the flow chart is the activity diagram is that the UML behavior, UML behavior that represents the workflow of the stepwise activities of the activity. So while if we're going to compare it with the flowchart, it's a graphical diagram that represents the sequence of the steps to solve a problem. Even though both of these have similar symbols, there is a distinct difference between the activity diagram and the flowchart. So let's move on to the last part of our discussion, which is the chapter summary. So in this area, so UML notation provides comprehensive notations to define specification. First is use cases describe functional requirements. Number two, class diagrams define data of system. Number three, OCL allows expression of detailed functionality and data properties. Number four, state machines plus activities can precisely describe behavior. And last but not the least, sequence diagram can give examples of behavior.